Hi, I'm Amy. In calculus, you're expected to be able to come up with the sines and cosines of multiples of 30 degrees, 45, 60, 90. You may not need to memorize them, but you need to be able to come up with them relatively quickly. So I'm sharing with you some tips in this video of how you can do that without a whole lot of memorization. The 45, 45, 90 right triangle is isosceles. We know that the two non-right angles are 45 degrees. They're equal. And that means then that the two legs are also equal. I'm going to mark the hypotenuse as a length of 1 because that's going to be equivalent to the radius in our unit circle. And I'm going to call the two equal legs x. So to figure out what that x length is, we can use the Pythagorean theorem. X squared plus x squared is equal to 1 squared. And then that means 2x squared equals 1. That means x squared equals 1/2. And that means x is equal to plus or minus square root of 1/2. Now I'm going to stick with the positive square root here because we're just talking about a length. So x is going to be equal to the positive square root. Square root of 1 is 1, and then that's over root 2. Now I can leave it just like that, or I can multiply by root 2 over 2. Maybe your teacher wants you to only use the rationalized version of this value, and that would give us root 2 over 2. So either of those are acceptable lengths for the 45, 45, 90 triangle. If you superimpose that 45, 45, 90 right triangle on top of your unit circle, of course the hypotenuse is still 1 because that's the radius of the unit circle, and you see the two legs I've marked there. That means that the coordinates of this point right here are root 2 over 2, comma, root 2 over 2. Now, if you're looking for the sine, for instance, of 45 degrees, this reference angle right here would be opposite over hypotenuse. So the sine of 45 degrees, or the sine of pi over 4, would be equal to root 2 over 2 over 1. Well, anything over 1 is just itself. So the sine of 45 degrees is root 2 over 2. And the cosine of 45 degrees would be that adjacent side over the hypotenuse. And of course, that is root 2 over 2 over 1 also. And we'll just leave the over 1 out of it. So it's nice to know anywhere on the unit circle that the x component of the coordinates refers to the adjacent side, and that is always going to give you the cosine, and then the y component is going to refer to that opposite side, and that is going to give you the sine, because of course that hypotenuse is 1. I've drawn in the other three triangles that also have a reference angle of 45 degrees. And since each of those legs on those triangles are root 2 over 2, I've included the appropriate coordinates where each of those triangles hits the circle, including the positive or negative where it's appropriate. So if you were asked, for instance, to find the cosine of 7 pi over 4, here's a thought process that I would go through if I was a student. Okay, pi over 4, I need to count up to 7 pi over 4. There's 1 pi over 4, 2, 3, 4, 5, 6, and 7 pi over 4. Cosine tells me I'm looking for the x value, and therefore the cosine of 7 pi over 4 I know is positive root 2 over 2. For the 30, 60, 90 triangle, it's helpful to start with imagining a equilateral triangle where all three sides are equal to 1, and then all three angles, of course, are 60 degrees. If you imagine cutting that equilateral triangle right down the middle, then you'd end up with this green triangle we have here, which is a 30, 60, 90 right triangle. Of course, that long side, the hypotenuse, is still a length of 1. We've cut the bottom length in half, so now this leg is 1/2, and we can use the Pythagorean theorem to figure out the missing side. So x squared plus 1/2 squared is 1 squared. That means x squared plus a fourth is equal to 1. X squared then is equal to 3/4, and x is equal to the plus or minus square root of 3/4. Again, we only really want to look at the positive square root for now just because we're thinking about lengths. So that would be x is equal to square root of 3 on top, and of course the square root of 4 is 2. So root 3 over 2 is the longer of the two legs. Here's that 30, 60, 90 right triangle superimposed on the unit circle. So you'll notice that the reference angle is 60 degrees, and I've included the side lengths. So of course the coordinates, the adjacent side, the x, is a half, and the opposite side, the y value, is root 3 over 2. So again, if I was asked for cosine, that's the x value. If I'm asked for sine, that's the y value. I've drawn on the other three triangles with the reference angle of 60 degrees, and I've gone ahead and marked their coordinates where they hit the circle as well. And again, all the lengths, the short side is a half, the long side of the two legs is root 3 over 2, the hypotenuse is 1 in all of those triangles. So when I marked the coordinates, I just marked appropriately which was negative and which was positive, depending on what quadrant they were in. So if you're asked, for instance, to find the sine of maybe 5 pi over 3, here's the thought process that I would go through if I was a student. First of all, okay, pi over 3, those are the multiples of 60. So there's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, which is equivalent to 300 degrees. I know that's going to be a 30, 60, 90 triangle. And the way it's situated, I know I'm looking for sine. That is the y value, and that y value is the long side of the triangle. The long side is root 3 over 2, and it's down, so it's going to be negative root 3 over 2. I've gone ahead and drawn in the four triangles that have a reference angle of 30 degrees. That's there in orange. And I went ahead and put in the coordinates there as well. You'll notice that the coordinates are flip-flopped from the 60-degree reference triangles. It's just the same triangle just laid down on its back, basically. The long side is along the x-axis, and the shorter side is the y value. So if, for instance, you were asked to find the cosine of maybe 5 pi over 6, pi over 6 is that 30-degree reference angle, and we're going to count through all the multiples of 30, or pi over 6. So there's 1 pi over 6, 2, 3, 4, and there's 5 pi over 6, 150 degrees. So cosine, remember, is the x value. And so we're thinking, okay, the x value of that triangle, if I lay out that triangle, there's the x value. Oh, it's in the negative direction. It's the longer side of that triangle. So that's going to be negative root 3 over 2. The last thing I want to talk about is how to find the sine and cosine for all of these points like 0, 90, 180, and 270. First thing you need to think of is, what are the coordinates there? So for here, for instance, it's 1, 0. So that tells me that the cosine of 0 is 1. The cosine of 360 is 1. And then the sine of 360, or the sine of 0, is 0. Up here, the coordinates are 0, 1. So I know the cosine of 90 is 0. I know the sine of 90 is 1. Etc. and etc. The x value gives you cosine, the y value gives you the sine.